we exist by and large because of the ethical obligation our customers have to make sure that pacemaker works and to make sure that ADAS safety system responds correctly and to make sure that autopilot system works correctly. And so I think it's kind of at the core of what we do in a weird way.
Welcome to The Future Of, a podcast by Fresh Consulting, where we discuss and learn about the future of different industries, markets, and technology verticals. Together, we'll chat with leaders and experts in the field and discuss how we can shape the future human experience. I'm your host, Jeff Dance. In this episode of The Future Of, we're joined by Elijah Kerry, the software director at National Instruments, to explore the future of test automation. Elijah, thanks for joining us.
Thanks so much for having me.
Good stuff. I want to share a bit more of your background and then get more of your thoughts, kind of your journey in the space. But Elijah is the director of the NI software community. He brings nearly 2 decades of expertise in the test and measurement industry. He's held numerous positions at National Instruments, including Chief Product Manager for their software platform and LabVIEW, which is a big part of National Instruments and their worldwide leadership in the space and test automation. I'm really excited to have you hear more about how you've contributed to their product management strategies and managed a lot of teams to do a lot of big things, historically, but also as we think about the future. Tell us more about your career kind of in test and national. Like, how did you land there? What contributed to your focus?
Yeah, happy to. So I started at National Instruments in 2007, straight out of college. And I had a strong background in software. I'm a computer engineer by background and degree. And my initial assignment, which took me into product management, was really around talking to the market and our customers about how to actually build large, complex software. Because up until that point, I think the market and our products were already at the beginning stages of a transformation as our customers migrated from simple laboratory automation to something slightly more complicated. And I think it's really interesting to examine what that was at the time and what that is now and how it's changed. But at the time, it meant that a lot of people that self-identified as not software people, so think electrical engineers, mechanical engineers, aerospace, chemists, physicists, suddenly we're doing more and more with software as a means to their ends, right? Whatever they were trying to automate or measure, interact with. And a lot of our customers were reaching a level of complexity and sophistication that suddenly they had to understand these software concepts that they weren't classically trained in. And so my initial role as a product manager was both to help the market understand how to use our tools for that level of sophistication, and then also to make sure we were investing in the products to serve those types of use cases. And I guess one of the examples that comes to mind is at that time, most test engineers had never heard the phrase source code control, right? Everybody was zip files and underscore final and underscore final two, and that was just how people did it. And fast forward today, I would argue most everyone that is building even a modestly complex test engineering piece of software is familiar with these tools. But that gives you kind of a window into the state of things at the time. And we were right there trying to help our customers master it and then also making sure our tools worked really well with it. And that was my initial focus.
Yeah. I would say in our history of Fresh, for the last 8 years being involved in LabVIEW and hardware test automation, we've seen a lot of evolution of software best practices, methodologies, and more kind of merge in with the LabVIEW work and the test automation. Definitely seen it here as well. Well, to kick off, I think for our audience, many might not exactly know what test automation means. It can have different things in different contexts, especially with software and hardware. But in the context of hardware products, test automation typically refers to the use of specialized tools and systems to execute testing processes without manual intervention, ensuring that kind of the hardware works efficiently and correctly. This differs, of course, from test automation with other software development, let's say mobile app development or digital products, which focused on the software performance around all the different tests where something might break. Anything you'd like to add kind of to that definition for today's conversation, help people that are maybe less familiar with test automation to understand this space?
Well, I think when we say test automation, we're, as you mentioned, talking about interacting with the physical world, right? Testing something physical, mechanical, electrical, versus I think you mentioned an app and just pure software based test. So
Yeah.
as far as the definition, I think it's somewhat self explanatory. It is interesting to consider the extent to which there are so many unique challenges derived from having to talk to real stuff and measure real signals.
Right.
And it's interesting to consider how that impacts and influences how you automate things and the nature of
Hmm.
software and the tools that go into it. I do think that there's a lot of things that people don't really fully understand or consider in advance of trying to automate something that actually has to talk to the physical world. And that's really what we do and what we've built a platform and tool chain to really focus on and help our customers try to master those unique challenges. So it's only a definition, um, but as defined, like the words taken literally, test automation. There's a lot that goes in there, and so I guess
Yeah,
I would
yeah.
offer that we're really focused on the physical world and automating interaction with that.
Yeah. And then for those that aren't engineers, you can build things in lots of different ways. People think like, software or even firmware or the way you construct hardware might be more mathematical. Um, when the reality is, it can be creative and you can do it in lots of different ways. So testing the outcomes, the performance of something physical or even digital, right, requires a lot of testing, a lot of tests that are set up to make sure that it's stable. Because when you build something of scale or that you need to rely on, that's critical, let's say in a space system, then you can't really have a lot of errors. Errors do happen, and typically bad consequences happen as a result of that. And when you're trying to produce something with a lot of scale, you could bring a company under if you produce something. If you made thousands of something, millions of something that didn't work well. So test automation's just critical from a business perspective when you're thinking about scale, when you're thinking about stability. And NI National Instruments under Emerson is a central part of that. I would say worldwide emphasis. You guys have been a big part of that space for the last what dozens of years now, probably.
Well, we're actually coming up on our 50th anniversary, so you can look for
Yeah.
a lot of fanfare and celebrations of that. We were founded in '76, and LabVIEW's coming up
Wow.
on 40 years. So yeah, I mean, our origins were our founders at University of Texas Austin trying to figure out a better way to take data from an oscilloscope. So think green phosphorescent displays and do
Yep.
something more with it than just writing it down on a piece of paper, right? That was kind of the initial impetus. Was surely there's a way to get this into a digital context where I can do more with it. But you mentioned and accurately described the criticality of test. I think one of the interesting challenges that we face and the industry faces is if you speak with most young engineers that are coming straight out of college, and I'll include myself in this,
Hmm.
I think everybody wants to go design stuff and build stuff.
Right.
And no one considers or really understands the role of test, at least straight out of school. I know I didn't personally.
Yeah.
They think building rockets and designing cars and circuits and all these amazing things, or writing software, whatever it is. Oftentimes, that's what compelled many of us to become engineers in the first place.
Yeah.
And so, when you get to industry, the notion of test and I think people understand I've got to make sure it works, but the level of
Right.
sophistication and automation really required, especially as you get to some of these really complex apps,
Yeah.
is often underappreciated. And so one of the
Yeah.
challenges is you've got people building spaceships or satellites or cars, whatever, and they've got to hire engineers to build and write these test automation systems. And they're like, no,
Yeah.
I want to design stuff. So part of it is education on the role and frankly, the coolness, right? You get to break stuff, you get to blow stuff up, you
Yeah.
get to, push it to its absolute limit and find out what failed and improve. And so
Hmm.
there's a, I personally feel like there's an opportunity to make engineers better appreciate and be excited about the role of
Yeah.
test in building the applications you spoke to a minute ago.
It is fun, and I think you're right that it's underappreciated. Yes, we want to create things and design things, but I think the value, the innovation requires not only creation, but you have to have value in innovation. It has to work essentially. You want to get to something that you can launch, that you can see that's out there in the world versus just a prototype or something or concept or something. That's fun too. But real innovation it reaches a market. It penetrates something. It adds value. It has return on investment. Otherwise, it's just creative. It's just a concept. It's just an idea.
We we
Um,
we found a lot of traction. We do work with students at various universities all over the world,
yeah,
and we've in recent months and years been more deliberate in focusing on the students that are having to build something physical. So we
yeah,
had Trell on stage with us at NI Connect talking about the rocket that they're trying to launch to the line of space. It's big, IDAR controlled project, and as you can imagine, it's got to work. So suddenly, those students are thrust
work.
into a world where they understand the role of test, and they're doing closed loop control to test
Yep,
the motor controllers on the rockets. And similarly, you can point to Formula SAE organizations or robotic competitions, and suddenly those settings and those students
yeah.
suddenly really understand the role of test.
And I think, test. I can say from our company, and I would say we're a cool like design and engineering company. I think definitely has a sexy kind of cool part to it. So it can have a bad reputation on the surface level. But I think you're right that there is a really cool part to it, and the notion of pushing something to its limits is really interesting. And in our work, sometimes we've designed dozens of systems to test a product through a lot of different stages of something. Maybe we're testing the accuracy of something. Maybe we're testing whether it's waterproof or not. And so this ancillary sort of development of systems to test something is fun. And to your point about robotics, there is an automation aspect to this, and automation sort of akin to robotics. And so those that are involved in test automation work, it's not a far leap from robotics work. And in fact, we do a lot of robotics work at Fresh, and so and sometimes we're using NI's hardware software because it's built for testing, and you need to do a lot of testing with robotics work because when you unleash something, it there can be risk, right? There's
Yeah.
there's the risk side, there's the scalability side, there's a reliability side. So
Well,
glad we kind of level set on this up front.
can I say one other thing? I know we're still effectively in the first question, but it occurred to me too
Yeah,
that when you talk about test automation and what it means, the role of it, and even pushing something to its limits, it's also a broad term in the sense that if you're automating tests in a production facility that's cranking out millions of devices on a manufacturing line, that's
yeah,
very different from trying to characterize and understand something that you may not fully know what the failure modes look like. And
right.
having spent time in the EV world, I think battery cells are a great example of that. And so there's also an element of exploring the unknown and the known unknowns of
Mhm.
trying to like will this what is the longevity and lifespan of the cell? What are the leading indicators that it might have some sort of internal short or defect
Yeah.
that could and so even if you zoom into interaction to the physical world, there's a very big difference between activities happening in a lab that's looking at a prototype and trying to characterize its longevity and characteristics
Mhm.
from production. And there's a lot of things in between. And you throw in remanufacturing and like test is a critical activity that looks very different across the entirety of technology product life cycles.
Right. Yeah. It's not just design, build, test.
Right.
It's design test, it's build test, and then it's test. Like there's a lot of testing that should go along. Good design actually has a lot of testing in it as well. And so I think that philosophy of test and that being a critical part to building something is it needs more education. Hence this podcast. Hence your guys' sort of worldwide leadership and the work you're probably doing at universities to help get this right up front. We've had great engineers come out of school that have taken test and LabVIEW seriously, and then they understand the full life cycle of building great things. So glad we talked about that. As far as how LabVIEW, I know you've been kind of at the leadership helm from a software perspective, but also from LabVIEW perspective. How would you characterize LabVIEW, in its position in the world of test automation, especially in comparison to Python, which has been picking up some steam, and I know there's room for both. But how would you characterize, LabVIEW, within test automation and then also in comparison to Python?
Yeah, it's a great question, and I have the right coffee mug for it. Um, so the Python's a fantastic tool, and by the way, even though I'm in management, I still make a point of using LabVIEW on a regular basis and working with customers, but also Python and other tools and languages. I think NI philosophically has always embraced a multitude of tools and programming languages and make sure customers can use them all and even interact between them. But to your point, like what is the unique use case or value for LabVIEW in a world with all these tools? And there's a reason that there are dozens, hundreds, depending on how you count, of different programming languages in this world, right?
Mhm,
Python is often thought of as a tool that a lot of people use and it's very approachable and it's true. But there's a reason that there's also .NET and C Sharp and C++ and firmware languages. Like there are. It's I think the key is let's make sure we're using the right tool for the job at hand. And again, Python, fantastic for quickly getting some code working and rapidly prototyping and sharing and exchanging IP. It benefits from a huge ecosystem. LabVIEW has really been built from the ground up and has proven uniquely capable of interacting with the physical world. Now,
mhm,
that's worth unpacking because, of course, our drivers and lots of other drivers are equally available for other languages, including and especially Python. But it's what you then do with the data and how you manage the interactivity with those systems. Because just talking to one single device to digitize something, sure, fine. Give me the data. No big deal. However, you look at most test automation systems, you'll find, well, it has to talk to the DUT. It has to talk to the handler. It has to talk to a scope and to maybe do some RF measurements and has to switch through a matrix for signal pass. And suddenly you're at the mercy of the physical world, right? Like you need to be able to communicate with all of these devices independently, asynchronously, and without one of them disrupting or altering in a negative way the rest of the system. And
mhm,
so the syntax of LabVIEW, specifically the graphical data flow that it uses, was really built out of a desire to represent physical data and real signals from real systems and has proven over decades of use and scale the most productive and performant way to manage that in a complex software architecture. And so we
mhm,
encourage and support people interoperating with and using Python. But I think the concurrent nature of talking to all these different devices and the fact that it's not a software only system, you are at the mercy of that physical system and what it's trying to do and how quickly it will respond makes LabVIEW uniquely valuable and capable for test automation. Again, where you're talking to the physical world. And that's just one point, but I think I'll start with that and
yeah,
invite your thoughts and feedback. I think there's lots of other things that people would say are really compelling about LabVIEW, but I think that's something derived from the unique nature of test automation that has
mhm,
really given LabVIEW a 40-year uh, market leadership position in that space.
yeah. I think one of the things we have noticed inside at Fresh, having a LabVIEW kind of user group, hosting a LabVIEW community here in Seattle, and having a lot of integration with National Instruments, is that it's fast, it works, um, it's specific to kind of the task at hand, and like you said, the multitude of avenues that it needs to connect to different aspects of the product development kind of test automation side. I think to your point about Python being broad and kind of connected to different ways, and different communities, and advancing as well in a unique way, that with a lot more support infrastructure kind of frameworks along the way that are also tailored for this space is true. I my gut would be like, "Hey, it's like a 50-50 split in the community kinda worldwide, that, like, 50% of people are using Python and related other frameworks, and then maybe 50% using NI, and there's pros and cons to both." Would you say that's a good generalization, or do you guys have data behind that?
Well, as far as the
Just for
split,
test automation. Just for
yeah,
test automation.
Um, I would struggle to put a number to how I would divide the set of users that use LabVIEW versus Python or other tools. I mean, for one thing, there's great examples of people being successful using both in the
Both.
same
Yeah, yeah.
application.
Fair.
So I think
Use the
as
right
it
tool for the right job.
well, and in a weird way, I don't really view Python as competition. And I know a lot of people do, or they at least ask, and it's usually coming from LabVIEW users who really like LabVIEW, and they want to understand and explain to Python developers how and when they should use LabVIEW.
Mhm.
Um, I I view LabVIEW as a complementary tool that, or sorry, Python as a complementary tool to LabVIEW that is really good at rapidly prototyping and getting something working quickly. But it's not something that anyone, even outside of test automation world, is going to put into large scale, high performance, mission critical systems, especially when you care about determinism and real time performance. And from a scale and reliability perspective, the fact that it's loosely data typed introduces some debugging challenges at scale when coordinating with teams of developers. So I view it as a fantastic tool for getting something working quickly or playing in well-defined sandboxes. But it is, I don't think, I think you reach a level of performance reliability where it may not be the best tool for the job. But I really see it as complementary, and the other point I'll make too about Python is it benefits from a huge ecosystem, right? The number of
Yeah, yeah.
people and repos and libraries might be, but it's a very large dynamic range of use cases.
Right.
Versus if you get LabVIEW programmers together, they are overwhelmingly immersed in the same fields with common
Mhm.
challenges and experiences. And I think there's tremendous value in the LabVIEW ecosystem. I was just at GDevCon in Chicago a few weeks ago, and you can get several hundred users together in a room, and they are talking through a very common set of challenges and use cases in test automation. I think there's tremendous value in the fact that LabVIEW and the IP that's been built around it really serves as targeted use case test automation.
Yeah. Thank you. Appreciate that perspective. You mentioned community, and I know NI hasn't been part of Emerson for too long. That's my understanding. I don't remember how recent that happened, but is Emerson ramping up kind of investment in LabVIEW, and how is the community kind of contributing to the innovation that's going to happen in the future?
I mean, two good questions in there. One, really, what is the future in this Emerson world, and then what is the role of the community? The We'll start with the Emerson one because I think it's a pretty simple answer. I think
Mm,
the acquisition by Emerson was rooted in their recognition of the tremendous value of our core business, right? The thing that built the company uh, back in 1976. That simple, like let's talk to the physical world and digitize signals and great hardware and software to serve that use case. So I think Emerson is really focused on the core products and technology that built the company. So think LabVIEW, DAC, PXI, and all of the platform tools that most people know is for it. They expect and are behind a really exciting future for those products, as hopefully is demonstrated by some of the announcements since the acquisition,
mhm.
including the increased investment into LabVIEW and a pretty impressive portfolio of new DAC products that are actively rolling out as we speak. So
Nice.
for the average user, I think it's NI as they've known us for many decades. If anything, it's somewhat renewed the focus on those core products and revamped our commitment to them. So
Mhm.
uh, I but the proof is in the pudding. We're a little under 2 years in, if my memory serves correctly, and I think we already have a lot of great proof points to illustrate that, and there's more to come. Um, from a community perspective, uh, the I think one of to my earlier point about GDevCon, one of the most valuable aspects of LabVIEW is actually our community.
Mhm.
And it's really amazing what they've done with our tools and with events and with IP. And so a lot of my focus and my team's focus is empowering them. You mentioned your user group,
Yep.
which I had the pleasure of attending. That was the end of 2024.
Yeah.
Uh, throughout throughout COVID, and even just with our shifting focus in recent years, we
Mhm.
saw a lot of user groups which were entirely run by our community stop meeting. Right? Physical events in general stopped meeting. A lot of people went
Yep.
virtual.
Yep.
So we have seen user groups come back with a vengeance just in the last year, more than quadrupling the number of user groups meeting every quarter. And we are working with community leaders all around the world to increase that number. GDevCon, I kind of point to as like the ultimate user group. And so these events are fantastic forums for people to share and exchange ideas. But beyond just events, we're also working with our community to tap into their enthusiasm and empower them to engage with students and universities, as well as in the core IP of our products. So we've open sourced more and more of NI's products or parts of NI's library products, and we're actively working through increasing the number of open source repos with a deliberate focus on empowering our users to contribute back to our products using their experiences and expertise. So all of those are examples of how we're seeking to really empower our community uh, to create value for all of our users and the market overall.
Thank you. Let's shift to the future a bit and talk about where things are going. What do you see changing in the next 10 to 20 years? That's a big question, but you've been there for a while, right? So you've probably seen some things that are, where we're looking ahead. You've been in the space, kind of interested in your forecast.
Yeah, I've been there since I had a full head of hair. Um,
Nah.
so obviously AI is on the top of everyone's mind right now, understandably so. And has announced some exciting investments into AI. But putting those aside for the moment, I think there is a pretty remarkable change and evolution for the engineering community overall, but more specifically for test automation. And so going back to what I mentioned earlier about my initial role, it was helping a lot of non-software people understand the role of software and how to really manage more sophisticated software projects. And I think what we've seen is an almost predictable progression as industry and our customers move from simple automation to more and more sophisticated applications. I think there's almost a predictable progression of the needs and the challenges and the tools and the dynamics of the team that many of these organizations have to really understand and master to achieve their business goals. So
Hmm.
many customers in very different states of maturity and sophistication. So part of it is those organizations are evolving continuously as a result of just their own market pressures and many of them trying to achieve scale or higher product volume, et cetera. And then that means that if you look back over the last 20 years, we've taken a lot of engineers who didn't have a strong software background and turned them into software engineers. A lot
Yeah.
of test engineers are really increasingly experts in the software and the role it plays in automating these applications. And now, whereas they were talking about source code control, now they're talking about abstraction layers and containerization and heterogeneous distributed compute and being able to scale up and scale out the performance and computational tasks of their test automation layers, and doing so for very large scale manufacturing environments or very sophisticated validation labs. And so now those types of trends and technologies, I think, are the things that a lot of test organizations are thinking about how to incorporate. And now AI on top of all that just creates so much opportunity. So much, in fact, I think many organizations are struggling to figure out how best to first incorporate AI. The obvious example is,
Hmm.
well, I'll use it to develop my software. But then you
Right.
think about the data and the composition of the systems and the specification of the systems. Like AI is transformative across all of those, and I is working rapidly to incorporate that. So I guess a long-winded way of saying organizations will continue to evolve. You're seeing that rate of evolution increase. AI will create more opportunities for rapid transformation for these organizations, and uh, we're we're working directly with our customers to make sure those types of technologies and capabilities are made available directly in our products.
Yeah, that's great. That's good to hear. I think if we look to the future and how fast things are moving from an AI perspective, I would assume if you weren't doing that, the future wouldn't look very bright. But given the community that you have, the fact you're already underway and hopefully things are coming soon, I could see that really enabling all the strength that you have now. I think McKinsey said like if technology companies aren't incorporating AI in the next 3 years, they might be on a path for obsolescence. And I just think that's how fast things are moving for software and technology oriented companies. You guys are right there at the center. LabVIEW has like a visual side to it, but then also the software side to it. Is there like an aspect of AI? What we've seen so far with AI is a lot of text oriented things
Mhm.
and visual oriented things, but the reality is anything can be vectorized, right? In a sense, like anything digital can be vectorized. And then that's why we have AI music and AI videos and AI UI and like
Mhm.
everything AI, because any information can be vectorized in a database, and then they can recombine those vectors with a neural network and produce something with a prompt. Um, so I'm just curious, as we know, as our main interfaces so far, our experience, at least for the first year and a half with AI, was like imagery and
Mhm.
text. And as we think about the future of what LabVIEW looks like, is there a compilation of both? Not just help with writing software, but is there like will the visualization part be vectorized as well?
So it already, in a way, is. If you go into our tools today, you can launch our AI assistant and begin to ask it questions about the code. And the most obvious vector of investment you're going to see is continuing to improve that. And that's what using
Okay.
standard LLMs like ChatGPT under the hood to enable that. And from there, right now, that's really focused on the user experience. So if I'm new to LabVIEW, or if I'm inheriting code that I don't really understand, or I need to find IP to serve a certain use case, it's really built around kind of that elementary novice user and helping them be successful and ramp up in the code or the libraries, et cetera.
Hmm.
But
Hmm.
as it becomes more capable and understands more of the overall context of the use case and even becomes capable of generating code, you can imagine it becomes a far more powerful tool than a development context. And all of that is very much in our roadmap. And thanks to the exponential increase of AI's capabilities, you can expect to see that uh, evolve fairly rapidly in the product. So that's the obvious intersection of,
Trajectory.
well, yeah, that's one obvious, like based on the current data point that you have or the current
Hmm.
release, development workflows are going to be an initial target for sure. But
Yeah.
it's not just that. It's then again, as I mentioned, what hardware do you select, right? You integrate systems, right? Even just selecting the right set of instrumentation and the fixturing and worry about cable lengths and interference and thermals, like that's a non-trivial task. And so it can potentially play a huge role in that. And then data. I keep harping on the battery example, but a lot of people produce a lot of data when they're measuring the internal impedances of a battery, and then
Hmm.
they don't really know what to do with it. And there's a
Right.
lot of other examples of application areas just like that where you can acquire a ton of data. And if you go back a few years ago, there was even people, pundits talking about, well, it's really about the right data. And now it's like, no, it's actually about getting a tremendous amount of data and being able to correlate that with outcomes and then using LLMs and AI to actually more intelligently predict and understand what that means for the quality and longevity of the product. So those are just some examples of where AI can go well beyond the bounds of purely development task in the test
Hmm.
engineer's workflow to make us all more productive.
Yeah. That's great. So multiple points of integration for AI right now. We're at kind of that base case of having an assistant that kind of helps or augments, but it'll be a lot more vast, a lot more comprehensive. And will we get to the point where like you could just throw in a prompt and get a lot of output?
So short answer is yes. I mean, you can already throw in a prompt and get output. I think the question is like, what's the role? What's the value of that output? My personal feeling is, when talking about architecture and complex system design, I talk a lot about sandboxes, especially as you get into teams of developers, right?
Right.
If you have novice developers, you want to get in their sandbox, well-defined APIs, a very specific task, and make sure that's fitting into a larger system architecture that they may not fully understand, and that's okay. You have the architects that understand and manage that. And
Right.
I think
Right.
AI will initially be really good at playing in those sandboxes. I need a script that does this very specific set of things, and I'm a developer, but I don't like finessing the characters to manage strings and like if an AI tool can do that for me or do the math, great. I care about the system architecture. But
Right.
stands to reason over time it will become more and more capable of understand and helping out at a larger and larger scale. Um, so I don't know. It, AI is so exciting and evolving so rapidly that it's hard to say definitively what it will be capable of in just a few years' time. But at least for the next 3 to 6 months, like we have obvious line of sight to some very exciting improvements that will
Mhm.
rapidly increase the impact it'll have for our users.
Yeah. That's great to hear. Technology, is definitely speeding up. AI has been a big part of that. It's also converging, and I think that's where it gets interesting when you provide more context. All right, if NI the NI ecosystem has a lot of context to
Mm,
not just the code, but some of these other connected systems, then the ability to do more at just a prompt, right? If it has that context is really interesting as we think about the future. One of the things you mentioned was containerization kind of things speeding up
mm.
there as well. So how do you see that helping as we think about AI and containerization kind of moving hand in hand?
Good.
Any thoughts?
Yeah, yeah. So if you rewind back to again when I had a full head of hair and started in this role, at the time, software resiliency came down to test it to make sure it's bulletproof. Right,
Yep.
and that applied to the systems we were testing, but then all the test software that our customers were writing. A lot of our customers are building satellites or autopilot systems or safety critical systems, defibrillators or pacemakers. Point being, they've got to work. And so the test software
They gotta work.
has to make sure that they work. And then how do you guarantee the test software works? And I think some of the software standards, which still exist, so I think about like their regulations, like here's DO 178, and there's various CFR requirements from the FDA and automotive standards. I think the mindset has, and to some extent still is, like make sure it will never fail. Make sure it will never have a problem. Make sure it will never have a bug. Now, as software has become more large and complex, I think the reality is setting in that that's almost impossible, right? You
Mhm.
want to understand the risk profile and mitigate the most pressing risks, but then you also want to make software resilient in the sense that you anticipate and respond to failure. And so containerization is an interesting technology because as you containerize your software, part of the value is well, you can update and manage these components independently and you can scale them up and scale them out, but they can also fail. And the system can recover them independent of what the rest of the system is doing. So I think the
Mhm.
containers have a lot of interesting implications, one of which is the approach to large scale test software architectures and how to make them resilient fundamentally shifts.
Mhm.
It also has implications for how you automate development activities and continuous integration and continuous deployment types of workflows, which a
Mhm.
lot of our customers are increasingly doing. We actually just launched a new version of LabVIEW with a Docker Hub container
Right.
for that
Right.
version posted.
That's great. Yeah, I just would anticipate, I think containers allow us to kind of combine multiple technologies, right? Into
True.
and so as we think about AI, being and coupling that with the advancement of containers, like, being able to continue to abstract out into like larger nodes of creation or support becomes really interesting.
Yeah. Yeah. And
Well,
how
that
you communicate between those containers, like technologies like gRPC are also increasingly relevant and important for our customers. So we've done a lot to support gRPC, the driver layer, and within LabVIEW. So um, there, and then by the way, not only you have AI and heterogeneous software components, but then you can have heterogeneous compute too. Right? You think about FPGAs,
right.
real time and determinism, and then the analytics, and there's a lot that is enabled as a result of this distributed system architecture and user
Mhm.
containers.
Yeah, that's great. So other thoughts on the future, we talked about AI a little bit. We just talked about containers. You talked about how NI is, doing a lot now for the future. But do you have any other thoughts as we think about where things are going? Maybe, and that could include test automation as well.
Yeah. So the the I think the good news is that, well, the good news for us at least is that we play in industries that are rapidly evolving. And
Hmm.
so as soon as you figure out how to build something at scale, right, it's time for the next permutation of that device. It's time for the
Right.
new technology, the new cell chemistry, the new chip. And so by definition, we really serve a rapidly evolving landscape of technology companies that require bespoke, custom solutions to, again, interact with the physical world. So I think a lot of our
Uh-huh.
technology trends and investments are driven directly by the technology arcs that are impacting our customers. Um, and so when it comes to the future, our resolve is still to make sure that they have the tools they need when they need them as they become relevant and applicable to the systems they're building. So AI is certainly an example of those. Containerization is an example of those. Even just being able to I think one noticeable trend that we're really focused on too is just the sheer volume of systems and the data they produce. So gone are the
Yep.
days of like, I have 5 test systems and I walk around with a USB drive to collect data from them or push new software to them. So now a lot of our focus is on tools that can scalably support dozens, hundreds, even thousands of different systems, the software
Mhm.
configuration and the data coming from those, not to mention being able to understand and visualize the data coming from all those systems. So I think that's one of the
Yeah.
trends I'm really excited about because first off, some of those applications are just cool by their very nature, but you have
Yep.
so much complexity that now you need this other layer of management to really understand and coordinate the activities of the system. And I'm referring to our product System Link and its
Yeah.
capabilities for connecting and managing all those systems.
No, that's great. I think, I think the history of hardware has been more contained, not as connected. But as we think about the future, a lot of the future of a lot of hardware is software. And the future of software is also AI, right? So like this notion of data connection and distributed systems and thinking about how you're getting more real-time information versus periodic information from USB drives, is really that seems to be a kind of a pertinent part about where the future is going. You've seen since System Link's been brought to pass how much has changed in that space, right? And I can only envision that the future test automation is much of the same, right?
There's
Where
still
we just
plenty of
have the expect.
customers that are walking around with a USB drive, I must say. But I think everybody recognizes that there's a better way once you reach a certain level of scale and complexity.
Yeah, that makes sense. Does ethics come into play at all as we think about the future? Is there like a anything that you're worried about or that we need to be thinking deeper about as a community, especially with AI and AI being connected to physical systems? That's a big question,
Yeah.
but just wondering if you have any thoughts offhand.
Well, I think there's the obvious considerations around what data are you using to train it on, how do you ensure the privacy and protected nature of customer data, and so we are very much following best practices from leaders in the software industry. So think, Microsoft and the likes. A lot of our customers, especially working in secure or highly regulated environments, they have their own secure cloud or their own secure LLMs, and they will never, nor should they, allow their data or their code to be shared with a public LLM. And
Hmm.
so for us, it's more about making sure that those types of topologies and use cases are equally served by our tools so that our AI capabilities can be integrated into these secure facilities and these sanctioned clouds. And certainly from a training perspective, we would never use private customer data to train our tools. So from an ethics perspective, though, um, uh, it's the engineering community has a huge responsibility in what we do and the types of applications we build.
Hmm.
And the it's funny because I would argue that test by its very nature is an ethical obligation of our customers, especially if you're
It's an
building.
element of trust.
Yeah. And so I guess I've worked it on a whole career in part because I really enjoy the breadth of customer applications that we serve and I get to see some really amazing uh
Hmm.
engineering applications. But we exist by and large because of the ethical obligation our customers have to make sure that pacemaker works and to make sure
Yeah, yeah,
that ADAS safety system responds correctly and to make sure that
right.
autopilot system works correctly. And so I think it's kind of at the core of what we do in a weird way.
Yeah. I mean, we just wrapped up a project for a medical device company where we were working for 6 months to do hundreds and hundreds of tests, right? Like, um, and get something ready for FDA, acceptance. And people have no idea, right? Like, when you have what goes into that sort of testing. But I would agree that NI has played a role in that, an ethical underpinning to what we're putting out there in the world, and how we support its reliability.
Right. And
And to your point, security and privacy as well. Now that we think about integration with AI,
well,
yeah.
and I should have I mean, from a hardware perspective too, I think we strive to give the best in class hardware from a performance accuracy perspective. So the data you get is good data. Um, something I should have spoken to is also just cybersecurity, and that's a
Hmm.
huge focus for us. And part of it is
Good.
is driven by very aggressive laws and regulations coming out of the European Union around cybersecurity and software resilience. And we are investing significant resources into making sure that our customers have all the data and all the artifacts they need, and that we are shoring up the security of the tools and technologies that we use in our products. So that is actually a very big focus for us as a company, both, and just it's no secret that cybersecurity is really important in this modern era.
Yeah. New AI is taken, given them more power, and we need, we need more planning, foresight, implementation, to kind of counter what's coming as well. I think we're already seeing that, but I would say that wave's just starting.
Yeah.
Thanks for that. Just closing questions. Any other, advancements in test automation that you're excited about that could be, now for the future? And then, what's been one of the what's been kind of really rewarding? You've been in this space for a while. What's kind of been the rewarding part of being in your career, kind of in test automation? Those are two kind of closing questions, but can repeat them if needed.
No. So other things I'm excited about. I think there's a lot to be excited about. From I mean, my worldview is really from the NI perspective. So I think we're making some really exciting investments into our products. I think Emerson has given us a renewed focus on our core technologies, and we've already touched on some of the key technologies and investments that I'm excited for. Uh, Nigel and our AI tools being chief amongst them in terms of what it stands to be able to do. We also have a renewed portfolio of DAC products. We came out with Neo DAC. So I don't want this to sound like a shameless sales pitch, but I think the investment into our core products is really compelling. And I'm certainly buoyed by the enthusiasm I'm seeing amongst our customers. Um, the other question was, remind me.
Yeah, just what's been a rewarding part of your
Oh,
your uh, your career being in this
yeah,
space?
yeah. No, I love that question because I already mentioned it briefly, but part of why I have been here as long as I have is I have a front row seat to some of the coolest applications in the engineering community. And I'm a technologist through and through. I love technology. I love engineering. I love what it can do for humanity and the world. Um, I have had the good fortune of, seeing the Large Hadron Collider deep underground in Geneva, and some of the coolest engineering and rocketry applications, and static fired engine tests of various rockets, and visiting customers all over the world. So I think for me, I could pick on any one of those as an example. And of course, I always have to think what I'm allowed to talk about. Um, but I think it's awesome to realize like the shared nature of the engineering community and our users and their passion for what they do and the role that our products play in serving them. People generally like our products because it's enabling them to do these really cool applications. And
Right.
uh, I love and get out of bed in the morning because I want to make sure that our tools are still the best at doing those amazing things and building those amazing
Hmm.
applications. And I genuinely love and enjoy every opportunity I have to get out there and see how our products are really powering these types of transformative applications. So I mentioned the Hadron Collider. I also had the good fortune to visit the National Ignition Facility, Lawrence Livermore. We did a great case study there about the energy research they're doing. But there's so many more, and I'm really excited for the role our products play, perhaps more the role of just the engineering community and advancing outcomes for all of humanity, or making the world a better place, right? At the risk of being
Yeah.
cliche, I genuinely
Hey,
believe
no,
it.
that's great. No, I mean, you are in a unique position, right? Because test is so important to the future of physical technology development. And because you guys are a world leader in that space, you get to see the things that are being worked on for the future, right? You do get a front row seat to kind of some of the exciting innovation that's coming from a broad perspective. So I do think that's unique. Hence our interest in chatting with you. But Elijah, thank you for your insights, your dedication to test automation, to kind of the future where this is going, the ethical underpinning of that you articulated. Grateful for you being on the show and the preview, a preview really of the future of test automation.
Thank you so much for having me.
The Future of Podcast is brought to you by Fresh Consulting. To find out more about how we pair design and technology together to shape the future, visit us at freshconsulting.com. Make sure to search for The Future of in Apple Podcasts, Spotify, Google Podcasts, or anywhere else podcasts are found. Make sure to click subscribe so you don't miss any of our future episodes. And on behalf of our team here at Fresh, thank you for listening.